Welcome back. In this section, we'll be finding exact trig function values for angles that are 30, 45, and 60 degrees. We'll be doing this using these two special triangles, and they both are right triangles where we have in one of them angles that measure 30 degrees and 60 degrees, and the other where they measure 45 and 45. The 30, 60, 90 triangle, where that one comes from, in case you're curious, is from equilateral triangles. If you were to take that 30, 60, 90 triangle and put it next to a mirror image of itself, you'd see that what we have would be a triangle where all three angles are 60 degrees and where the side lengths would all be 2 units. So yes, this is exactly where it comes from. That 30, 60, 90 triangle is an equilateral triangle that's been cut in half. The second triangle, the 45, 45, 90 triangle, that comes from taking a square whose angles are all 90 degrees, and if we had a square whose side lengths were all 1 and then cut that square in half, you would now have two 45-degree angles in that triangle along with that 90-degree angle. So these two triangles we'll use, and we'll use them to find our exact values for our trig functions at 30, 45, and 60. One little thing as far as the remembering things goes, people usually are pretty good at remembering which angles go where and which side lengths go where for the 90, 45, 45 triangle. And often people will get the side lengths and the angles mixed up for the 30, 60, 90 triangle. And so the thing to remember for the side lengths, remember that whatever the smallest angle is, the smallest side is opposite it. And whatever the largest angle is, the largest side length is opposite it. And the middle side length, root of 3, is about 1.7 approximately. That's opposite the other angle. So that's how I remember which side is the 1, which side is the 2, and which side is the root of 3. But any way you do it, these are the two triangles we'll be doing to evaluate our trig functions. So we'll start with the first one, sine of 45 degrees. And so for that, we're going to need to use our special triangle where the angles are 45, 45, and 90. And the side lengths are 1 and 1, and root 2 for the hypotenuse. And for sine of theta, sine is opposite over hypotenuse. So if we're thinking about the 45-degree angle, the opposite side measures 1, and the hypotenuse measures root of 2. So sine of 45, that would be 1 over root of 2, which in simplest terms would be root 2 over 2. For the other two parts here, for part B and part C, we're looking at angles that are 30 degrees and 60 degrees. And for both of those, we're going to use the same triangle, the 30, 60, 90 triangle. And so now if we're looking at tangent of 30 degrees, tangent of 30, tangent is opposite over adjacent. So tangent of 30 should be opposite, which is 1, over adjacent, which is root 3, or in simplest terms, root 3 over 3. If we want cosine of 60, cosine of 60 is the adjacent side, which measures 1, over the hypotenuse, which measures 2. So cosine of 60 degrees should be 1/2. Okay, so we're going to complete the table below. And I'm going to first, before I do anything, write in my two special triangles, just so that I have them handy and ready to go. So I've got my 45, 45, 90 triangle. whose side lengths are 1, 1, and root 2. And then I've also got my 30, 60, 90 triangle, whose side lengths are 1, root 3, and 2. All right, so first, before we do any of the trig functions themselves, we have to talk about the angles. So this is, again, something that we're going to have to get used to, is seeing our angles in terms of radians. So I have them written in radians, but I'm also going to write them in degrees. Pi over 6 radians, if you converted that to degrees, you would find that that's 30 degrees. Pi over 4 radians, that's 45 degrees. And pi over 3 radians, that's 60 degrees. And when I complete this chart, I'm going to still remember all of those identities that I had relating our different trig functions. So you could fill out this entire table thinking strictly in terms of opposites, adjacents, and hypotenuses. Or you could think about things like tangent is sine divided by cosine, for example, or that secant is the reciprocal of cosine. Those are the sorts of things that might help you fill out this table a little bit faster. So I'll start with sine and cosine, and then we'll fill in everybody else afterwards. So for sine of 30 degrees, sine of 30 should be opposite over adjacent, opposite over hypotenuse, rather. That should be 1 over 2, or 1/2. Sine of 45 degrees should be opposite over hypotenuse, 1 over root of 2, which in simplest terms is root 2 over 2. Finally, sine of 60 degrees, that should be opposite over hypotenuse, root 3 over 2, and that is in simplest terms. And so there we go. We could do the same thing with cosine as well. So you could go through the exact same process here. You could say, for example, cosine of 30 degrees is adjacent over hypotenuse. You could do that. Or you could use some of the other little facts and theorems that we've learned. So we know, for example, that sine and cosine are cofunctions. And so you know that sine of 30 and cos of 60 should be equal to each other. Or sine of 60 and cos of 30 should be equal to each other. So if you're thinking about that complementary angle theorem, that might be how you find out for yourself that cos of 30 should be the same thing as sine of 60, or root 3 over 2. But of course, you can also justify that by looking at your special triangles and saying cos of 30 is adjacent over hypotenuse, root 3 over 2. So any way that you want to do it, we can find out cos of 30 degrees is root 3 over 2, cos of 45 degrees, root 2 over 2, and cos of 60 degrees is 1 over 2. Once we have all of these, it's easy enough to fill in the rest of our table. So I'll do secant and cosecant, just using the fact that I know that the reciprocal of sine is cosecant. So that means that if sine of 30 degrees is 1/2, cosecant of 30 degrees is 2 over 1, which is just 2. Sine of 45 degrees was 1 over root 2, so that means cosecant of 45 degrees should be root 2 over 1, which in simplest terms is root 2. And then finally, cosecant of 60 degrees, we know that sine of 60 degrees is root 3 over 2, so cosecant of 60 degrees should be the reciprocal of that, 2 over root 3, but in simplest terms, that would be 2 root 3 over 3. And you could do the same thing for cosine and secant, that since they're reciprocals of each other, you could say that Cosine of 30 degrees is root 3 over 2, so secant of 30 degrees should be 2 over root 3, which again, in simplest terms, is 2 root 3 over 3. We have cosine of 45 degrees is 1 over root 2, or root 2 over 2. So secant of 45 degrees should be root 2 over 1, which is root 2. Cosine of 60 is a half, so secant is the reciprocal, 2 over 1, which is just 2. And then finally, for tangent and cotangent, you could, again, think in terms for tangent of being opposite divided by adjacent, or you could think in terms of being sine divided by cosine. So you could say that tangent of 30 degrees is 1/2 divided by root 3 over 2, which is a half times 2 over root 3, which is 1 over root 3. Or in simplest terms, 1 over root 3 is the same thing as root 3 over 3. And you could do the same thing for the remaining entries. Tangent of 45 should be root 2 over 2 divided by root 2 over 2, which should just be 1. And tangent of 60 degrees should be root 3 over 2 divided by 1/2, which if you do the work on the side, you'll find that that's root 3 over 1, or the same thing as root 3. And you could do the same thing for cotangent. You could say, well, cotangent is, you could say it's either adjacent over opposite. You could say it's cosine over sine. You could say it's the reciprocal of tangent. And all of those would be ways to get to the final results for what are cotangent of 30 degrees, 45, and 60 degrees. So you could find out that cotangent of 30 degrees is root 3, cotangent of 45 degrees is 1, and that cotangent of 60 degrees is root 3 over 3. You can also use the fact as another identity, how tangent and cotangent are cofunctions of each other. So cotangent of 30 degrees and tangent of 60 should be equal. Tangent of 45 and cotangent of 45 should be equal. Tangent of 30 and cotangent of 60 should be equal, and indeed they are. So what I'm trying to impress upon you is that there are a variety of ways to justify the answers that are in this table and also find the answers that are in this table. So we should know our basic definitions for our trig functions, but we should also know all those other relationships because those can help make our work a little bit easier for us to do. Now, there are going to be some times where we do need to find an approximate value using our calculator. And so there is going to be a few instances where we will need to find out what might be sine or cosine of some angle. Now, we have on our calculator 3 different buttons, sine, cosine, and tangent, which will give you the functions sine of theta, cosine of theta, and tangent of theta. If you're looking for the other trig functions, secant, cosecant, and cotangent, you don't have them as special functions on your calculator because the calculator is expecting that you'll know that they'll be the reciprocals of those functions. So, for example, if you wanted to find out what is secant of 10 degrees, you would actually think about it as 1 divided by cosine of 10 degrees, and that would be how I would find the value of secant of 10 degrees using my calculator. The other little thing to be aware of here is that our calculator measures angles not just in 2 different ways, but in 3 different ways, in degrees, radians, and gradians. And you'll see at the very top of your calculator in the little display window, it'll either say DEG, RAD, or GRAD, and that's how it's telling you how it's measuring its angle, whether the angles are being measured in degrees or radians or gradians. And to go from one way of measuring it to the other, you'll need to push the button that's on the top of the calculator that says DRG. If you haven't already, this is a nice time to watch the video that I have on evaluating trig functions using your calculator, so you can see that happening in action. The one other part that I want to be careful about here, like I say, if you're looking for the other three trig functions, secant, cosecant, and cotangent, you would do that by expressing them in terms of sines, cosines, and tangents. The one caution here, you might notice above the sine button, you'll see sine with a little -1. Above the cosine button, you'll see a little cos with a -1. And above the tangent, you'll see a tan with a -1. And my caution here is the -1 does not mean power of -1. It doesn't mean reciprocal. What it means is inverse. Just like we had back earlier when we were talking about inverse functions, sine with the -1 is the inverse of the sine function. We will be talking about that in Chapter 8, but for now, that's the thing that you need to know, is that you're not going to be using those functions, sine with the -1, sine inverse. You won't be using that to find things like cosecant, unfortunately. So if you do want to find things like tangent, cotangent, and cosecant, you'll need to express them in terms of sines and cosines and tangents. You'll also need to make sure that your angle is being measured the correct way. So if I ask what's the approximate value for sine of 10 degrees, your calculator will need to be in degrees. If I give you sine of pi over 3 radians, then your calculator needs to be measuring angles in terms of radians. Also, the final part to mention here is the pi. If we're doing things in terms of degrees, that is exactly the same pi that you had from geometry, and it's the same pi that you have as a function on your calculator. It's the same 3.14, etc., that we've seen in the past. So if we're finding the approximate values for these functions, then we would start off with, if we're looking for sine of pi over 10, that's in radians. So first make sure that your calculator has angles measured in terms of radians, and then I would enter this in my calculator as the sine function, left bracket, pi divided by 10, right bracket, and I find that that's about 0.309016, so approximately 0.309. For cotangent, that's the same thing as the reciprocal of tangent. So first off, we're looking for cotangent of 23 degrees. We'd have to make sure our calculator is in degrees mode. And if it is, then we can go right ahead and say, well, we want 1 divided by tangent of 23 degrees. And when we hit equals, we'll get about 2.35585, so about 2.356. And for the last one, secant of 3 pi over 20, so we're talking radians. So first make sure that your calculator is in radians mode. And for secant, that is the reciprocal of cosine, so I would enter 1 divided by cosine, left bracket, 3 times pi divided by 20, close my bracket, and I get approximately 1.122 and thereabouts, so about 1.122.